All right, so 4.1 questions. Number 3 says 4.2 questions. Number 3. It's not even Monday. What's my problem? All right, so sample for a poll. So there are about 15,524,971 adults in Florida. If a Gallup organization randomly selects 1,068 adults without replacement, are the selections independent or dependent? So let's talk about this first. Without replacement means what? Independent, right? Because like in our previous problem where we talked about pulling balls from that Powerball, right? That since we pulled the ball out and we didn't put it back, the denominator was changing every time. You guys agree? Yes. So that means the probability was changing. Therefore, that would be dependent. Like that right there is dependent. So that's why this is, since it's without replacement, means that this is, what is it? What is it again? Dependent. Dependent. That's correct. Yep. Your sample is getting less every time, right? So your denominator is changing. So your probabilities would definitely change. If the selections are dependent, can they be treated as being independent for purposes of calculations? Well, we have this 5% guideline for purposes of calculation. If this sample, right there, this 1,068, is less than 5% of this size, then you could actually just treat it as independent. So then what that means is you could just do the denominators without changing. You can just keep the denominators consistent because if you calculate the probability both ways, it'll be so close that it won't matter. So I bet you have a problem in here in a second that'll kind of prove this. So what I'm going to do is I'm going to see if this 1,068 is less than 5%. So 1,068 divided by that 15. I have a feeling. Yeah, this is going to be fine. Yeah, that's way smaller than 5%. You guys agree? Oh, my bad. So this times 10 to the minus 5 means that decimal is going to move to the left 5 places, right? So this is extremely small extremely small percentage. You guys agree? It's very, very much less than 5%. 5% being 0.05. Okay. So yeah, you can treat it as independent. We say it's the 5% guideline for cumbersome calculations. And I bet you we have one in here. If not, I'll try to find one, and then I'll calculate it both ways and kind of show you that it doesn't really matter. Number 4. Plus you, rule of complements. When randomly select an adult, let B represent the event of randomly selecting somebody with type B blood. Write a sentence describing what the rule of complements is telling us about P of B or P of B complement being equal to 1. So, let me do that piece of paper. Let's talk about complements. Like heads and tails. What's the probability that if I flip a coin, I get heads or tails? Well, what's or mean again? That's pretty clear though. Let's do the calculation though. So what's an or statement mean? What's the operation for ors? Add. So this is going to be equal to the probability of heads plus the probability of tails. Yeah, minus probability of both at the same time, right? Both same time. Okay. So what's the probability you get a heads? 1 out of 2. What's the probability you get a tails? What's the probability you get both at the same time? If I flip a coin, what's the probability that is both heads and tails? Okay, so it's 0, right? It's not going to be both. So notice how being heads and being tails is what we consider complements. Like, actually, what we'd say is, as being heads is actually the complement. It's actually the complement of being tails. It's the other one. Does that make sense? Like, being a boy is the complement of being a girl. Is that clear? Now, complements don't overlap at all. These things are disjoint sets. So it means they don't overlap. They're not jointed. So, what we mean about that, if you add, say, if you say what's the probability of B or B complement, it's the exact same thing as this. Does that make sense? That I know I kind of have it backwards, but this is the same thing as tails complement or tails. You guys agree? Because heads is tails complement. Complement being the other one. I hope that is kind of clear. Like you're either a smoker or you are a smoker complement. The complement of being a smoker, which is a non-smoker. Does that make sense? Okay, so disjoint sets, that means you're either in this group or you're in this group, and these things are disjoint. And that's all of that, right? You're either one or the other. You guys agree? Okay, so that's what I mean by complement. So what's the probability of B or B complement? Well, this is everybody, right? Either being a smoker or a non-smoker, that's everything. So what's the probability that I pick a smoker or a non-smoker? 100%, right? I don't know their probabilities exactly. Like boys and girls are, heads and tails are 0.5 to 0.5, right? The smoker to non-smoker might be, this might be like the probability of a smoker or a non-smoker. I'm making these probabilities up, so just if you want to look them up for yourself, smoker plus the probability of a non-smoker minus the probability of both. So I'm going to say the probability of being a smoker is like, I don't know, let's say 18%, so 0.18. So if the probability of being a smoker is 18%, what's the probability of being a non-smoker? It's got to be, right? It's the complement of the other one, right? It's got to be the rest of the people. You guys agree? So this has to be equal to 0.82. Minus, of course, a 0 because they're disjoint sets. So this is always going to be 100%, right? Pen's dying. Or 1 is what we say. So 100% is equal to 1. You guys agree? It's the same thing. So it's decimal 1, 2 over. Okay. So that's what they mean by this. Is that that's everybody. B and B complement. That's everybody. Great. Oh. Did somebody?
We'll check it out.
Whatever. Let's get it done. Okay. So it says it's up there now. We got to answer it now. It's on the board, right? Okay, so when an author observed a sobriety checkpoint, when the author observed a sobriety checkpoint conducted by the Dutchess County Sheriff Department, he saw that 676 drivers were screened and 6 were arrested for driving while intoxicated. Based on those results, we can estimate that the probability of being intoxicated is, I'm assuming that's what I means, is either equal to this 0.00888. Where I denotes the event of a screening driver or getting someone who is intoxicated. Okay. What's the probability of I complement denote?
Non-intoxicated.
Does that make sense? You're either intoxicated or you're not intoxicated. Do you guys agree? You're either going home or you're going to jail, right?
So wouldn't you do 1 minus probability of I?
That's correct. Yeah. So if we know. Back to this exact same thing, right? If I knew the smokers was 18%, I knew that the other one was going to be 0.82, right? So the probability of being a non-smoker is equal to 1 minus the probability of being a smoker. I know you guys basically did that in your head. You guys agree?
Yeah.
Yeah. So that was equal to 1 minus 0.18. So that's how we got that 0.8. Ah, my goodness, 0.82. So that's how we got that. So if we want to find the probability of I complement, which is the probability of not being intoxicated, you just take 1 minus this number, right? Does that make sense? So let's just put it up here so you can see it. 1 minus 0.00888, right? Yep, is equal to, it's pretty high, right? Most of those people are going home. You guys agree?
Yeah.
Okay.
Considers what you call home.
Yeah, agreed. Yeah, that's true. Most people are not going to jail. 13. I'm gonna zoom in. All right, fast food drive-through accuracy. If 2 orders are selected, find the probability that they are both from Taco Bell. Okay, so A, we're going to assume that the selections are made with replacement. And they're asking, are the events independent? We'll talk about that. And then next it says, assume the selections are made without replacement, and then we'll do it that way. Okay, so Unfortunately, I'm gonna need this. I'm gonna need this table. Okay, so. Zoom it out. Zoom it out. All right, so number 13. This was number 4. Okay. Number 13 says we're looking for what's the probability if 2 orders are selected? Find the probability that they are both from Taco Bell. So what they're asking is, what's the probability of Taco Bell? I got a question. Is it and or? It is and, right? So what's the probability you get Taco Bell and Taco Bell, right? What a great night. Get Taco Bell and... That stuff is amazing, isn't it? It's so awful for you, but it's so delicious. What's another way that kind of shows that they're probably talking about an and when you look at the problem? What are they also asking about?
That they're both. What, isn't it going to be independent or dependent?
You guys agree?
That's how you know it's multiplication.
Yeah, if it's addition or if it's an or statement, they talk about being disjoint, right? But if they're and statements, they talk about being independent, right? Does that make sense? It's kind of another kind of dead giveaway that they're talking about an and. Okay, so Taco Bell and Taco Bell. What's the probability the first person went to Taco Bell and the second person went to Taco Bell? All right, so since this is an and statement, what's the operation for ands? Multiplication. Okay, so this is going to be equal to, well, the first for A, so we're going to have to do A. We'll do them separately. A says assume the selections are made with replacement. So the probability of Taco Bell and Taco Bell is going to be the probability of Taco Bell multiplied by the probability of Taco Bell, right? Why did I not do any funny notation on this other part? Because they're made with what? What's this like? Yeah, with replacement, right? So this, the probability of this thing is not affected by the probability of this, right? Actually, if this probability is not affected, what do we say? Is that independent or dependent? Okay, so this is independent. Independent. This piece is really independent of the first one, okay? So what's the probability of Taco Bell? Taco Bell is right here. So you guys agree this column's Taco Bell?
Yes.
Okay, so what's 145 plus 13? 158. You guys know the total? And that the total, for those at home, the total is the addition of all those numbers, okay? Does that make sense? So if I add up the, both rows, you're going to get this 1,118. Multiplied, since this is independent, since this is made with replacement, this probability is going to also be what?
158 over 190.
Yep, so this is going to be 158 over 1118. So this is equal to 158 divided by 1118 times 158 divided by 1118. Can you guys see my typing? Does that make sense? Just kind of plug it in and just almost the way I write it. So enter. So I get 0.01. We got to do 3 sig figs, right?
Yeah.
So after the first non-zero number, which is this 1, I have to take 3, right? Unfortunately, what does the 7 do to that 9? It bumps it up, right? So this 199 is going to turn into what? 200. Okay. So it's going to bump up that number. Ooh, I'm not supposed to write on my calculator. All right. So that 199 is supposed to turn into 200. So this is 0.0200. Remember when you're supposed to do 3 sig figs for probability, right? Could I drop those zeros if I want on the end?
Yes.
Why can I drop these zeros?
They're just placeholders.
Yeah, are those numbers different? If the numbers don't change, you can drop the zeros, right? But if they do change, you can't. Usually I'm going to write it with 3 sig figs like this just so we get used to it, because probabilities are 3 sig figs. 3 non-zero numbers. No, 3, well, yeah. For starting with the first non-zero number, it's going to be 3 in total. All right, now let's do part B. Now, they're saying without replacement, so what are we talking about the events? Are they independent or dependent? Dependent. So that means the probability of the second one's going to change, right? This probability over here is going to change. So the probability of Taco Bell and Taco Bell is going to be the probability of Taco Bell multiplied by the probability of Taco Bell after I remove somebody that went to Taco Bell, right? Does that make sense? This is just the notation I'm going to use for removing somebody, because I don't want these two things to look the same, because they're clearly not. So this is going to be 158 all over 1118 multiplied by, what's the probability of this thing? Yeah, we've taken somebody from Taco Bell. You guys agree?
Yes.
So it's not no longer 158. It's what? 157. And also we've taken somebody from this total. You guys agree?
Yeah.
So it's going to be what?
117.
Good. Now we multiply. I don't think this is going to be much different. You guys agree? Numbers are pretty close, but it's going to be a little different. We do need to know. So,
Actually,
see how much different. That's a little. No, yeah, it's a little, right? If we do 3 sig figs, it's going to be the 0.0199, right? Because that 6 is going to bump that 8 up to a 9. So this is going to be equal to 0.0199. So they are different. You guys agree? The two numbers are different. I'm kind of curious if you could do that cumbersome thing. What's 158 divided by 1118? You guys see how that's the sample is bigger than 5%? That's why the numbers are a little bit different. 14% if I did it. Okay, so number 17. Probably going to need the table as well. All right, so number 17 says fast food drive-through accuracy. If one order is selected, find the probability of getting an order from McDonald's or Wendy's or an order that is not accurate. Ooh, ORs, I love it. This is awesome. Okay, so we got a triple OR, right? Or a double OR. We have 3 things. You guys agree? Okay, this is gonna be cool. Not supposed to get this excited, am I? That's all right. Whatever. Okay, so let me get over here. So for number 17, they're asking, what's the probability of McDonald's? Oops, I don't know. Or Wendy's? Or not accurate? So what we have to be careful of is when we do OR statements, what we're trying to do is we're trying to add in a way so that we do not double count. Is that clear? So I'd like to do this with addition statements, and then we can kind of double check it. You guys agree? Okay. So we know this is going to be equal to the probability of McDonald's. Well, what's the operation for OR statements? Addition. So McDonald's plus the probability of Wendy's plus the probability of not accurate minus any double counts, right? Minus any overlap. You guys agree? Overlap. Probability of overlap, let's just say that. The probability of overlap could be complex if they let me kind of show you guys a something that we have to be careful of. If we're like taking the probability of 3 things, we have something that looks like this. You guys agree? What we'd have to be careful of is, we'd be adding, this bubble, and then this bubble, and then this bubble, and we have to be careful of all this overlapping stuff. You guys agree? Okay. So let's. I'm gonna regenerate this thing and just kind of show you, because I'd like to just draw it on there, but I want to show you when you guys look at it at home. So accurate, not accurate. McDonald's Burger King, Wendy's, Taco Bell, 329, 33, 264, 54, 249, 31, 145, 13. Okay, so what I'm trying to do is I want to kind of do this overlap thing that I was doing in class. So what I want to do is kind of just mark them off. So when I asked for the probability of McDonald's, you guys agree that it's this? I'm adding all those numbers up and dividing by how many?
Yes.
So the probability of McDonald's is equal to 329 plus 33 is going to be what? 362? You guys get that?
Yep.
So that's 362 over that 1118, right? Because it's the same addition of everybody that we did in the last problem. Plus the probability of Wendy's is going to be this, right? Does that make sense? Okay, so the probability of Wendy's is going to be 249 and 31 is going to be, you guys get 280? All right. Love it when I have it right. 280. Done. Plus, I have the probability of what? Not accurate, so it's that, right? Is that clear? Okay, so I'm going to add those up. 33 plus 54 plus 31 plus 13. So when I add those up, I get 131. So the probability of not accurate is 131 all over the total. Minus, I have to subtract out the probability of overlap, right? Where do they overlap? Yeah, you can see it. Yeah, you guys see they overlap here? And they overlap here? That's right, yep. Subtract the probability of their overlap. So this is going to be 64 all over 1118. So what's kind of neat here is notice how these two, like when I drew this Venn diagram, those are not disjoint sets. You guys agree? They all overlapped everywhere. But what I actually have is I have McDonald's and I have Wendy's that don't overlap. But I got the not accurate that kind of overlapped them both. You guys agree? The not accurate kind of overlapped those two. So that's kind of what the Venn diagram would look like that we have to subtract off this 33 and subtract off that 31, right? I know it looks like Mickey Mouse, but... Alright, so I'm going to add all these numbers, and when we do addition, you know, the denominator doesn't change because they're all the same, right? So just add the numerators, combine the numerators through their operations. So this plus this minus this. What was it? Thank you. So 709. What was it? 0.634. Fantastic. Cool. What do you think? Okay. So we have to be careful of remember that your sums, you have to be careful of this probability of the overlap. That's really what you have to worry about. 22. Testing marijuana use. So if one of the test subjects is randomly selected, find the probability that the subject tested negative or used marijuana. So what we need is, let me write it down. So what's the probability that tested negative, right? So 22 says tested negative or used marijuana. So tested negative or used marijuana. So this says table 4.1. Where are you? Table 4.1. Probably this one, right? Refer to table 4.1. Is that it?
This is table 4 at the top.
What's that?
Table 4.1, it says right there.
Is that it?
The drug test.
Refer to table 4.1. So that must be this one. There it is. Table 4. You're right. It's right there. Sorry. Must be struggle busting it today. Okay. So for number 22, they're asking what's the probability that you tested negative or used marijuana, right? So or statements are what operation? Yeah, they're addition. So this is the probability of tested negative plus the probability of use marijuana minus the probability of both. You guys agree? Have to be careful of overlaps. Okay, so back to this table. So tested negative is what column or row? Can you guys see it? Probably not very well. Focus. So tested negative. Is it the first row? Second row? First column? Second column? Yeah, the one that says negative test results. You guys agree? Okay, so this is tested negative is this column. So I know I'm going to have to add that column. So tested negative, I'm going to add those two numbers. I have 485 all over. Anybody got a total for me? You guys get 555? Okay, 555. Okay, so that's that column. Then I have to say use marijuana. So uses drugs, I'm assuming must be this row. You guys agree? Because it says subject uses drugs. So we have this column and this row, right? So here and here. Agreed? Okay, so that row is 50 plus 50 out of that 555. Then I have to subtract off their overlap. And where'd they overlap?
Yeah.
Right here, right? At that 5? Does that make sense? They overlap right here. So it's 5 out of 480. So again, this column and this row overlap at that 5. So this is going to be 485 plus 50 minus 5 all over. So I have 5. Ooh, sorry, that should be 555. You guys agree? On the bottom. So this is going to be 530 all over 555.
0.955.
What'd you get, Scott?
0.955.
All right, I got what? Man, we're just kind of scooching into time. Let me see. If it's very similar, I'm not gonna. We're kind of out of
Can I
time.
ask you a question on number 9?
You might have to wait till break.
All right.
Okay, I'm kind of running out of time. I'm getting skinny on it. How about I will. Let's see. Is this the 5% one? The study of helicopter usage recent results. I'm out of time, guys. I'll hit these on break, okay? Or we can stay after. This is a long section, so we'll come back to it.